My name is André Bueno. I'm a front-end developer here on Bueno Code, and I'm here to present a bit about D3.js. So I'm going to pass by all of those topics here, starting with why you should use data visualization to your applications, explain a bit about it, the library, some fundamentals. I will give some examples, some alternatives. Then I will go to the challenge and give the references that I used to make this presentation. Hopefully everybody that are watching us are familiar to HTML, CSS, and terms like DOM. Have a little programming experience already. Have written some JavaScript code, and aren't scared of CSV, JSONs, and SVG stuff. First, I need to justify this course. So, why use data visualization on our applications? It's simple. Our system is extremely well built for visual analysis. It means that we can identify or we can interpret a graph, an image, better than a table. When we start to make one visualization, we should be aware of a simple rule. Data visualization is mainly the representation of pattern matching or pattern violation. Or you should, when we are creating a graph, if the data is uniform, you don't have variations, so you already know what you are dealing with. And if you have variations, it's the common case, you need to look with those two things. For things that are violating the rules, and for things that are matching the rules. So when you are creating these visualizations, you need to find those steps. Our brain has a singular way to organize the thoughts. Regarding that, there are a bunch of useful principles that make this construction easy. I'm not going to talk about that, but there is a field that studies these principles. The name is Gestalt. I have a link for that on the reference. But the principles are those ones here: proximity, similarity, enclosures, continuity, and connections. If you think your visualizations with those principles, you can make relationships easier than in a common way. There are many other libraries to use, and why I should use D3.js. First of all, it works on the web, so you can say that you know already other JS libraries that work on the browsers. It is okay, but back on the 2011 when D3 was built, we don't have many libraries that run only on the browser. We need to install a plugin. There is one famous that the name is processing. It's Java based, it's a Java applet that you need to install, and it's very heavy. D3 is also flexible, and it is as flexible as the client-side stack technology. If your HTML, CSS, and JS are improving, your D3 will be improved as well. D3 takes advantage of new features and technologies, and the depth of EA as a top browser is a good way, because now you have Chrome and Safari and Firefox are very powerful tools to renderize the visualizations. So it's a good thing. D3 also has great documentation, examples, and a huge community that shares a lot of stuff. D3 works similar to jQuery. So it's not a graph library or not a data processing library. Help the user to easily manipulate the DOM. It doesn't have pre-built charts, so if you are planning to use D3 for some simple things, my advice is don't use it. Use another library that already has everything implemented. But if you wanna add some different behavior and customization to your graph, you should use D3. D3 has, of course, some disadvantage, sorry. For me, the biggest one is the amount of work to implement some simple things. I'm going to show you one example later. And if you are talking about performance, SVG has a high cost if to dealing with. The browser does this a little not that good, but the browsers are getting improved every day, so I don't know if this could be a future problem. And if you have a huge amount of entries, if you have a huge DOM, this could be a problem too. Now I'm gonna dig into the library. There's two ways to load D3. You can just download the file or link directly to the latest release version into your DOM, just as I did here. As I told you guys before, D3 allows you to bind the data to the document object model and apply the transformations that you want. You can select the elements using the W3C approach, but it's kind of too verbose, so for me it's not that good. And we can do the same thing using D3. So D3 has a declarative approach that simplifies the works, and those codes does exactly the same thing. They are changing the color of the color of the font. It's a property of style attribute. This piece of code here shows a data that is being bound to a selection, and each element of the array being paired with some selection tag. So here I'm creating a P tags on the HTML and adding this tag to it. To be more specifically, back here we saw that we have this method. This is an important method. D3 has three main methods to you bind the data to your code. Those three methods are update, enter, and exit. The update is the default method. So if you don't specify anything, D3 you use it. This method will be triggered. But to be more specific, what does this method do? Updates take the elements that you already have on your DOM and bind the data below. If you can have the data on an array or on an external file, and this method binds the data to those elements of the DOM. If you have more data than elements, the elements of the DOM will be loaded until that point. You won't create more elements. Now, if you use the enter method, if you have an array size 10, if you have three P elements on your DOM, the enter method will create automatically the last 7 elements and bind the data to it. And the exit method is the other way. if you have more elements in your DOM, and it will remove those elements to have the same amount of the array length. D3 has a transition method. It's almost the same as the animation the carry, and the transitions are responsible to bring your visualization some different behaviors, kind of bring the visualization to life. Here's an example of how to change the size of every circle on a screen to some different size. On the tree we have a lot of objects already defined. So we have this here. We are using circles, but we can have rects, lines, paths, text, and many others that we're gonna check here. Now I'm gonna show an example to how to build a bar chart with D3, and I'm gonna show how to grow this visualization to make it better. Okay. Here I have a bar chart. Actually, on my DOM, on my HTML file, I already created this div. It's a div with a class chart, and I have this piece of code. I have an array here that contains data, and here I'm creating the x-axis on the graph. And the domain it goes from 0 to the maximum value of the data, and the range it's just to clarify what I want to show. I can increase the values here, as I know that the data, the maximum value here is 42. I'm using 412. So one pixel, one unity on the domain will be 10 units when the graph will be renderized here. This piece of code here is responsible to create those bars. So I'm selecting a div with the class is chart. Then I'm selecting all divs inside this div if I had one, and I'm binding this data and append this data into another div. And then I change the style and the width attribute in a style method to be the size of those bars. And then I created a text and added to it again. So this is how my DOM is right now. I created those divs here and I appended to this chart. This is not a good way to make a visualization. This is not a cool thing. And now I'm presenting here how to build the same visualization, but in the right way. I have already declared here SVG tag on the HTML, which has this chart class. Those attributes here, width and height, are appended here by D3. So first of all, I need to define which area, what is the size of the area that I'm going to use, and then I'm going to pass those values to create the axis and the area of the div that will hold the chart. This way is a good way to make it a responsible chart. You can You can even pass here some function, and this function will be, even if you resize the screen, this function will be traced, and your graph will be renderized again. We can pass the data to D3 with a lot of ways. The last example, we use an array, a JS array, but we can't always pass data just inside an array. So here I'm using an external file, is a CSV file, and I'm storing this all this content here inside this variable, and I'm doing a callback function here to analyze if I'm getting some issue during this loading. I defined the chart here as to make it easier for the browser, because I don't need to call it over and over again. So here I created this element here, chart, and I'm changing the size of it based on how many entries I have on this data, and I'm here creating the bar. So the bar will be binded with a data. The data is the thing that stored this file, and I'm transforming the size of this bar. I'm using the variables that I created here. As I told you before, the tree has a lot of different elements that I can use, and now I'm using rect. The rect is already built, this rectangle here, with a width and a height as you added before. So the width will be a function. So every attribute that you have on the tree that expects a value, you can add a function that returns some value, and you can make each element behave differently than the other one. Here I also appended the text. This is a good way to use, because it's a SVG, so you can scale your graph or add some zoom attributes here, and you won't lose any quality of the image. And this is a better way to build a bar chart than the way we did before, but it's not a good way too. So we are growing this visualization to another one that I'm going to show you guys here. So this is almost the same visualization. I increased the size of the data that I was using before, and here I have the SVG, the div that will hold the content. So I declare here first an object is a margin. It's to help me give you some white space between the top of the screen, the left, the bottom, and the right. I can even pass those values to recalculate the width that I'm passing to make it more harmonical. I don't know. So here I have this. I'm building on the tree. You need to code your draw. So for everything that you are building, you need to code. I have a x-axis here and a y-axis here, so I needed to build them. First, I'm building here. Oops. building here how the bars are gonna behave in the screen. So I'm passing a width, a size, and I'm passing the distance that I want from each bar, this white space here. So you need to be sure of almost everything on your graph. You need to pass where the element is going to be. Here I have a orientation, a bottom orientation and a left orientation for everything. And those ticks is how many ticks are those little pieces of here. You can specify how many of them you want and which is the text that you want to use, or which pattern you want to use. You can even change this legend here. You can pass a log function, decimal function, percentage function, whatever you want. So I'm creating a SVG object here that will store the SVG content from the DOM, and I'm loading a data into a variable here, making a callback if everything is right. This is important to if everything goes wrong, you have a log that will help you know in which part of your file is wrong. Here I'm appending G element. The last graphs I was using a div, but I'm using SVG now, so use this G tag. It's better because it's lighter and faster than the div. And I'm appending here the x-axis, and after I'm appending here the y-axis. As a default behavior, everything is horizontal, so I needed to translate. Actually, I rotated the x minus 90, and I'm binding some text. To it, and some attributes that will mean the size of the letter, the distance between them, other steps. The more important thing here is how I'm creating these bars. Now I'm selecting those bars here, and I'm doing this process again. I'm binding the data from that file, and I'm creating, as I'm passing an enter method here, I'm creating rects. So for each entry in the data, I will create a rect, and I will append this rect into this div, which the class is bar. So I can pass here lots of attributes, and I'm using here the letter. This is letter. It's the name of the column in the CSV file. The letter is the name of column on the CSV file, and the frequency is another one. So I'm passing the names to make this legend here, and the height will be a value that I have there. The difference between the other one is the other one was horizontal. The other one was a bar chart. This is a column chart. Since I transformed the orientation, it will behave like this. The main advantage of D3 is that you can manipulate the elements using JavaScript. You can even use jQuery to manipulate those things that you created. But jQuery doesn't work very well for SVG elements. And you can even use CSS. So I think I have some style tags here. So I have a bar, over, when I'm hovering, I'm changing the colors to brown, so it's very light. You can change here colors that you want and to customize it easily from your browser. So this is how it was created. For every div that I have the size. I can even change here the size. I can pass only 60 and the size will be fair. So the file was changed, the position, and I can easily customize here to see if I want to change some behaviors, to change the way that the graph is looking. It's a very light way to do that. If you try to use some other library, probably you can't do that because they are using some closed stuff like Canvas, and you won't be able to edit it. Now I'm going to prove why we should use D3, because for a bar chart, every library, every visualization library has a bar chart. So why use D3? With D3 we can do stuff like that. We can sort and we can animate this stuff easily, and it's a light way to do it. So let's go. The main structure is the same of that I used before, but I added those elements here. Actually, I added a checkbox input here on my DOM element, and I'm selecting, and I'm trying to see if there is any change on the status, on the value, if it's true or false. I will treat this function here. This function, I'm not getting into it, but this function is responsible to do this sort, and these transactions here are responsible to make this fun part, to make this animation. So probably you won't able to do this with other libraries, and or using D3 or using jQuery or other stuff. So I'm going to show another visualization, because bar charts are very common and we don't need bar charts for everything. So one thing that D3 can do is to hold this kind of stuff. It's an awesome tool, and it's a little bit slow because I'm with my inspect element here open, and the browser is trying to change every number there. But I think if I can close it, it's faster now. Okay, so let me try to show you how this stuff works. As I told you before, D3 doesn't have a lot of doesn't have pre-built graphs, but has a lot of functions that are responsible to maintain some kind of visualizations. We have functions that are only for graphs, only for columns, only for maps, only for different kind of situations. So here I'm just gonna explain a bit how this stuff works. I have this object here, this force. It's default, it's a predefined on the library, and you can use it. You can even change here. The charge means how is the force between those two circles. The linking distance is the size of this link here, this great stuff. You can even pass a function, so this function will be, the value will be returned as a some attributes that you want to pass, so you can even get some different size of links for a different situation. And you are doing this process here. This first process here is you need to perform in almost every visualization that you have, because you need to define the area that you want to explore on your browser and which elements are going to be defined there. So here I'm loading the data again, and I'm binding to one variable, but this data is a JSON, in a JSON with a collection of two objects. I have a node object there, and I have a link object there. And here I'm binding those objects to some predefined functions that are responsible to create the nodes and the links. The links are created. The links in the node are created at the same way, basically. And you can even specify here here I'm just specifying the stroke width. This stroke will be different as each value that it gets here. So you can check there is some links that are larger than others. And here on the nodes, we can specify, you can create a circle, and we can specify the size of it. This is a uniform, this is a 5 size, but you can pass a function here to customize, to change it. So each circle will have some different size. And here's the important part of this visualization, the part that you force and you link everything together. So you need to see which you need to know which link is the source and which link is the target. So we'll be able to mount this structure here. This creation will be binding to your data, and now I will show how the data is. I'm just I think it's force alpha 0, and I need to do that because if I want to inspect those elements here and the graph is still moving, those numbers here are always changing, so the browser crash gets really slow. Here I have so this file is huge. For each line I have one entry there, and each line is calculated, so it's a lot of calculations at the same time, but you saw that it's fast already. And for each circle I created this a node, and the property that I have a radius, but I can edit here just to check. The data is it's always changed. Here is the position that it holds on the screen, and here is the color that is responsible for silk here. This is another kind of visualization that you can explore with D3. It's a kind of cool one. I'm going to show you another. There is you can even build maps. I'm exploring the element circle. I'm using a circle here, and you can see that each circle has a different size of the node one. I'm using hover properties here from CSS. I'm holding those lines that I created for everything, and I'm using CSS to show them. If I have all lines here, my visualization will probably not have any meaning. This state here is a JSON file, so you are getting a JSON And with an external library from D3, you are binding this data into a variable and drawing this map. D3 alone doesn't handle this kind of visualization. You can't draw a map without an external library. So we have another D3.js that will hold this path. And everything here is on D3. You can do stuff like that. You can even color each one of those elements here in D3. This text is binded automatically when you hover one specific region. Here I'm going to show how the data is created. So it is actually 3 layers. Each one is a different has a different element. To create a map, you need this. You need to specify the path. So here it's all the coordinates that are responsible to draw the map into a screen. So it's a lot of numbers, and one file, one map file is not that huge. Maybe it's 10 kilobytes, so it's easy, and this render process is very fast. You can even customize each element, have access to it, so I can remove this one and it will be removed from the screen. Of course that I don't want to remove it, so I got it back. So I can add class to those properties and change it. The changes here. I think this, okay. The circles are created from a function that specifies the radio and the position. So the radio is defined for some entry that I have on my data, and the position is another external file that holds the geographic coordinates of the cities of our state, Minas Gerais. And those info that we have here belongs to this file too. You can even use D3 using a MongoDB, or using some MySQL. You only need to pass the data to JavaScript, and it will know how to handle it. These cells are responsible to create a space that will not overwrite the polygon that creates each one of those cities here. So I think I'm done for examples. I'm just want to show how D3 can handle everything, how D3 can show, can create those stuffs. I'll be back to the presentation. There are some alternatives good for doing graphs, but the behavioral often are not like D3. Most of it you need to concern how to pass the data into the library, and in the library you do the rest. I know that this polymath has the same approach as D3, but those other ones you just need to concern how you pass your data. I think InfoVis it's encapsulated D3. They already built some default functions with D3 and encapsulated, so you only need to concern about the data. I have a challenge for this presentation. It's to build a simple line chart and try to make some personal changes. You can order, add some tooltips, change styles, colors, sizes, or add a guideline. Do anything you want to do. Just try to be off those default libraries that we already have. And here the references that I used. This is the D3 main website. This is the website that holds some examples, some good examples, and this guy here, Mike, is the head leader of the D3 project. So it has the best examples. It's pretty awesome. This is a book. If you wanna read, wanna know a little bit more about D3. And here there is a link telling about the Gestalt elements principles that I mentioned before. I think that is all. It's just an introduction of what you can do with D3. And if you guys have some questions,